Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to start new chapter, that is polymers. Last class I have finished biomolecules. Now I am going to start polymers. First I want to introduce polymerization in a brief way. Copolymerization has been used by nature in polypeptides, which may contain as many as 20 different amino acids. Chemists are still far behind. Means polymerization is going on in nature, and without polymerization our life would have been very difficult. The use of polymers in the manufacture of plastic buckets, cups, and saucers, children's toys, packaging bags, synthetic clothing materials, automobile tires, gears and seals, electrical insulating materials, and machine parts has completely revolutionized the daily life as well as the industrial scenario. Indeed, the polymers are the backbone of 4 major industries, as for example, plastic, elastomers, fibers, and paints and varnishes. The word polymer is coined from 2 Greek words. Poly means many and mer means unit or part. The term polymer is defined as very large molecules having high molecular mass, means 10 to the power 3 to 10 to the power 7 unit. Between that, 10 to the power 3 to 10 to the power 7 unit. Between that, these are also referred to as macromolecules. Macromolecules, which are formed by joining of repeating structural units on a large scale. The repeating structural units are derived from some simple and reactive molecules known as monomers and are linked to each other by covalent bonds. This process of formation of polymers from respective monomer is called polymerization. Again, I am telling you, process of formation of polymers from respective monomers is called polymerization. The transformation of ethene to polyethylene and interaction of hexamethylene diamine and adipic acid leading to the formation of nylon 6,6 are example of 2 different types of polymerization reaction. Again, I am telling you, repeating you, the transformation of ethene means double bond, carbon-carbon double bond. The transformation of ethylene or ethene, you can tell, CH2. The transformation of ethene to polyethylene and interaction of hexamethylene diamine and adipic acid leading to the formation of nylon 6,6 are examples of 2 different types of polymerization. Means CH2CH2, ethene, CH2CH2 is have double bond. Okay, carbon double bond. If suppose you have taken in n number, a small n number, maybe 10, 15, 20, 30 like that. Okay, big number. Then n moles or n molecules we can tell. N molecules of ethene on polymerization. Here CH2, that is the repeating unit. Then it will form NCH2. NCH2 on polymerization. It will repeat CH2 n times it will repeat. Then you will write it CH2 single bond between the CH2 now you will write single bond and both side one bond will be opened, means a back valency will be opened for further joining. Correct? Carbon has tetravalence, you know. Then CH2 is there, then two valencies remaining on each carbon. Then CH2, between the CH2 single bond. Correct? And fourth one valence is outside. Both carbon has one valency outside. Total 4. CH2 2 valency, one valency is with making bond with other carbon. And this is 3 and fourth one is outside for both carbon. Then CH2 single bond CH2 whole n. This is the polyethylene, what we are telling, polyethylene polymer. Correct? This is the representation of polymer. C particularly for polyethylene. Poly means many. Okay, polyethylene. Then CH2 single bond CH2 whole n. That is the you can say polyethylene polymer. Like that way. Next example I am talking about the nylon 6,6. Then here two things you require, two different molecules you require, two different compounds you required. Then first is hexamethylene diamine and second is required adipic acid. Now what is the, I can say this thing, formula for hexamethylene? Then CH2 whole 6 and both side NH2 is there. CH2 whole 6, correct? And this CH2 is joining with 2 NH2. Left side 1 NH2, right side 1 NH2. And CH2 whole 6 is in the middle. Correct? Means CH2 6 times. And then you write NH2 and the end. And in the beginning also NH2. Then in a simple way you can write NH2 CH2 whole 6 again NH2. This is called hexamethylene diamine. Hexa word you are using because 6 CH2 is there. 6. Hexa means 6. Then hexamethylene, CH2 is called methylene. Hexamethylene and diamine because 2 NH2 is present in this molecule or in this compound. Then this is called hexamethylene diamine. And other adipic acid, what is its formula? Then chemical formula, then it is a CH2 whole 4 and both sides COOH group is there, carboxylic group. Right side and left side COOH group is attached. Means COOH, so you can tell like the CH2 whole 4 is in the middle. Left side COOH, right side COOH. This is adipic acid. Then if you will take a number, a small n number of hexamethylene and n number of adipic acid. Both are in n number. N is large number. Then equal number both you are taking. Then here what will happen? Reaction is very easy because COOH, correct? COOH and the end OH is there, and NH2 2H is there. Then out of 2H, now both are going to join. Then one H from NH2 and OH from the other adipic acid, correct? H from NH2 from hexamethylene diamine and OH from adipic acid. You know that they will form water and it will go outside. Then OH will go as OH will, when it will break, then OH will be negative, correct? Then carbon will become negative, correct? And similarly, when H will go as H plus, then N will become negative. Okay? Then here you can see OH minus and H plus, it will form water. It will form water. Now, after that, carbon was positive and now and nitrogen was negative because H gone as H plus, N became negative and OH went as OH minus. Hence, carbon became positive because that OH was attached with carbon, correct? Then now negative nitrogen and positive carbon will join and will make a bond. Then now big molecules you got. Then here all things will be the same. NH2 CH2 whole 6, it is as it is, and in the place of NH2 now only NH is there. Only NH is there, and bond is between N and CO. That bond is formed. Bond between N and C is formed. Then on C, one oxygen was remaining, that is with double bond. That oxygen and carbon bond is double bond, CO, that is remaining. And this side NH is remaining, and N and C carbon is, this bond is formed. Now nylon 6,6, this is called nylon 6,6. Then here both you have taken N number, hexamethylene N number, adipic acid in N number. Hence that finally you have to write this combined molecules, you have to write in bracket, big bracket, and outside down you write a small n, correct? Because it will repeat, this unit will repeat n times. That's why you are writing n. That repeating unit you will write in bracket, correct? Then NH2, in the beginning it was NH2, then one will be opened. One valency will be opened just to join, just for joining other molecules. And COOH, after joining in the end adipic acid, 2 COOH was there, then one COOH, OH is used up, then second COOH is remaining, then that OH you remove, that you think that OH has gone with other, then only CO will remain and one valency will be there, correct? In the place of OH you can write one valency. Then both side hand will be opened, one valency. In the bracket you can write NH CH2 whole 6, NH CO CH2 whole 4, C double bond oxygen CO, that is a C and O double bond is there. Then this is actually nylon 6,6 plus H2O gone, that already told, that is the side product. Then now why it is called nylon 6,6? What is the meaning? 6,6. Then here you can see CH2 whole 6 was there in hexamethylene. 6 carbon was there. Correct? That's why 1 6 is due to that. And other six you can see in adipic acid CH2 whole 4 was there. Then 4 carbon, and now 2 more carbon is there, COOH. That C, both sides COOH group was there. Then now 4 and plus 2, 6. Correct? Then total in molecules you got 12 carbon. But 6 is due to the hexamethylene, and other 6 carbon is due to the adipic acid. Then this compound is called nylon. Nylon 6,6. Then these two common example I have given for polymers. Okay. Then in daily life we use many polymers. Already I have given examples. Correct? Now classification of polymers. Then there are several ways of classification of polymers based on some special consideration. Okay, I will discuss classification of polymers, but I want to tell other examples of polymers. Then plastic buckets, plastic buckets, it is made up of polymers. Cups and saucers, made up of plastic. Children's toys, packaging bags, synthetic clothing materials, automobile tires, gears and seals, electric insulating materials, means gloves, what you are telling, rubber gloves, and machined parts. Correct? These are the examples of polymers. Okay. Now I am telling about the classification. Then under here some I told you that there are several ways of classification of polymers based on some special consideration. Then here first I am telling you natural polymers. Correct? And this is actually common classification of polymers. First is natural. Second is semi-synthetic polymers. Third is synthetic polymers. Natural, then semi-natural polymers, then semi-synthetic polymers, and then synthetic polymers. These are the common classification. Then examples of natural polymers, I am telling you, question is asked. Every time question example they will ask. Then natural polymers. These polymers are found in plants and animals. Examples are proteins, cellulose, starch, resins, and rubber. Some resins are also natural. Resins are synthetic also. Then examples I told you, proteins, cellulose, starch, resins, and rubber. These are natural polymers. Question is asked, you remember. Now semi-synthetic polymer. Its example is cellulose derivatives of cellulose acetate. That is, cellulose acetate is also called rayon. RAYON, rayon. Cellulose derivative I am talking about. Cellulose, not only cellulose, derivative. Cellulose derivative as example of cellulose derivatives is cellulose acetate. Cellulose acetate, also called rayon. This is the first example of semi-synthetic polymers. Second, cellulose nitrate. Correct? These are the usual examples of semi-synthetic polymers. Don't forget, cellulose acetate and cellulose nitrate. Cellulose acetate is called rayon. Question is asked. Now third, synthetic polymers. Means this synthetic means artificially made. And semi was also artificially made, but 50-50, not difficult. But synthetic polymers is completely different. Synthetic polymers, a variety of synthetic polymers as for example plastic, polyethylene, synthetic fibers. That is, just now I told you nylon 6,6. This is the synthetic fibers. Nylon also you might have seen sari nylon 6,6 are made up of nylon. Okay. Then this variety of synthetic polymers as a plastic. Example is polythene. Synthetic fibers, that is a nylon 6,6, and synthetic rubbers. Synthetic rubber, that is also called Buna S. S means here sulfur. Buna S. These are the examples of man-made polymers. Okay, artificially made, man-made polymers, extensively used in daily life as well as in industry. Now one common example I told you, common classification, correct? Then now come to the classification based on a structure of polymers, correct? The first one I told you, that is the common classification of polymers. Now according to the structure, that is called classification based on a structure of polymers. There are three different types based on the structure of polymers. First structure is linear polymers. Second is branched chain polymers. Third is cross-linked or network polymers. This is according to the structure. Little details I will tell you. Linear polymers. These polymers consist of long and straight chain. By name it is clear, linear. Correct? These polymers consist of long and straight chains. The examples are high density polythene, high density HDP in shortcut, high density polythene. Second example is polyvinyl chloride, PVC pipe. You might have seen PVC pipe. Full name is polyvinyl chloride. And these are the examples of linear polymers. It is just like a wave form, long wave, you can tell like that, long chain, a straight way. Okay. Simply you can write like just like a wave, not very high tides, small tides, up little down, again up down, like that way you can write, or straight also you can write. Second is branched chain polymers. These polymers contain linear chains having some branches. That is the low density polythene. High density is the linear polymers, and a low density is the branched chain polymers. Okay, branched chain polymers contain linear chains having some branches. Correct? Example is the low density polythene. Means here what I discussed, the linear polymers, that is a straight chain. But if there in their chain some branch is there, then that is called branch chain polymers. Okay. Now third case, this I told you, branch chain, that branch will be there. Third class, this case is cross-linked or network polymers. Name itself is there, cross-linked. It means here also chain will be there. Many chains will be there, and all chain will be joined to each other. Okay, that's why called cross-linked or network polymers. These are usually formed from bifunctional and trifunctional monomers and contain strong covalent bonds between various linear polymers chain. As for example, bakelite, melamine, these are the examples for cross-linked or network polymers. Here simple way you can write, if you by writing you want to show, then you can write different these things, linear polymers, and make join each you can say each this chain will join to each other by some linkage. Okay, suppose three chains are there, then in first and second will join, second and third will join. Suppose three are there minimum, then first can join with second, second can join with third, and also first can directly join with third. Correct? This is called cross-linked or network polymers. Okay, examples are bakelite. Second example is melamine. Now again further classification I am telling you, classification based on mode of polymerization. Okay, there are different mode of polymerization. Then this third classification based on mode of polymerization. Examples are addition polymers, and second is condensation polymers. How you are going to make polymerization? You can by addition also you can get polymers, means many units will join to each other. Correct? Then that is called addition. Many units will join to each other, but here nothing will come out. You have seen in nylon water was coming out. Correct? But here it is not like that. That is called elimination. If while joining making bond, generally H2O will come out, HCl will come out. Correct? Then means halide and H2O generally it will come out. That is called elimination reaction. But here in addition nothing like that. Simply all will join. In polyethylene, many ethylene will join to each other. Correct? Nothing will come out. That's why it is called addition polymers. The addition polymers are formed by the repeated addition of monomer molecules possessing double or triple bonds. That's if polyethylene means double bond. Double E means polyethylene, E-N-E. Polyethylene, E-N is there in the end. Polyethylene, T-H-E-N-E. But E-N means double bond. Then maybe double bond, sometimes maybe triple bond. Like example, ethine, E-T-H-Y-N-E. Ethine means triple bond, but ethane means ethene, not ethane. A-N-E, that is the single bond. E-N-E means double bond. Y-N-E means triple bond. Then the addition of polymers are formed by repeated addition of monomers molecules possessing double or triple bonds. Example, the formation of polyethylene from ethene means double bond, and polypropylene from propene. Propene means what? 3 carbon will be there. Correct? Propene, your structure you know. Then first example I told you, formation of polyethylene from ethene and polypropylene from propene. However, the addition polymers formed by polymerization of a single monomer species are known as homopolymers. You remember, this is a very important point. The addition polymers formed by the polymerization of a single monomeric species are known as homopolymers. Examples are polythene, common polythene, polythene bag that I am talking about. Homopolymers, when monomers will be the same, means CH2, n molecules you have taken, then you will get polythene, CH2 single bond, double bond becomes single bond. What happened to the other bond? Then now that bond broken. That's why one electron will be left on both carbon for the further joining with other molecules. Okay, that's why you can represent polythene like that, CH2 single bond CH2, and one bond keep it opened. This indicates one electron, and in bracket down you write N, because CH2 single bond CH2. This will repeat many times. That's why CH2 single bond CH2, and both side one bond will be there. But CH2 you can write in bracket, and outside you write N, down you write a small n. Then this is the example of homopolymer. Homo means same. The polymers made by addition polymerization from two different monomers. Now you have seen polythene only same monomer was there, but you will take more than one, means two different monomers. Then this is termed as copolymers, and process is called copolymerization. In the beginning I used the term polymerization. Different monomers will join here. Okay, this is a difference. Here both will join, but both will be different. Okay, two different monomers, when they will join, then that is called copolymers. Question is asked. Example is Buna S, Buna N, where S means here sulfur, N means nitrogen. Buna S, Buna N. This is the example of copolymers. Now I am giving this other example. That is 1,3-butadiene. 1,3-butadiene. How Buna S actually, Buna S, how it forms, that I am telling you. Okay. Then here 1,3-butadiene. 1,3-butadiene. Here butadiene means 4 carbon will be there. Butadiene means 4 carbon will be there. Then 1,3-butadiene means carbon number 1 double bond will be there, and carbon number 3 double bond will be there. All will be, other will be a single bond. Each carbon have one CH means CH2 and CH. In the beginning, first carbon, second carbon double bond. Second and third single bond means CH, second and third CH, and third and fourth double bond means third carbon 1 H and fourth carbon 2 hydrogen, means tetravalency of carbon is balanced in all cases. 1,3-butadiene. Now other you take example of styrene. Okay. Then here what will happen? Both will join. Then where it will join? C6H5CH. Styrene formula I am telling you. that here also CH double bond CH2 is there. In the place of one H, a phenyl group is attached, C6H5. One H gone, and in its place C6H5 is there. That's why this is called this thing styrene. Styrene means it is actually ethylene, but one in the place of one H, C6H5 is present. Correct? In the place of H, C6H5 joined. This is called styrene. Then N moles of styrene and N moles of 1,3-butadiene both will join. Then now where they will join? Then you know that where double bond is there, that bond will break, double bond will become single bond. Means a double bond that will, styrene double bond that will come close to the 1,3-butadiene. Correct? Both double bond from the butadiene, last carbon 3 and carbon 4 has double bond. Near that styrene double bond will come. Then for both molecule, for butadiene also 3rd and 4th, that double bond will become single bond. Correct? Then bond breaking means what? One bond will break, then both carbon will take 1 electron. 1 electron both will take. And this styrene also bond will break, double will become single. Then both carbon will take 1 electron. Correct? Then now you understand that this both carbon have single electron. Means in butadiene also and in styrene also. And both are close. Then both are now joining, adding. Then they will make a bond. Joining means they will make bond. Then styrene 1 carbon. Styrene 1 carbon, both carbon has single bond, but you consider only one. Correct? Which is close to the butadiene, that carbon. Then that carbon single electron have, and butadiene also that 4th carbon has single electron. Then now both will make bond. Both will make bond. Correct? Then now like that way, now it became long chain molecule is formed. But now you remember that 2 carbon now they have after making bond also each carbon has single electron, because bond broken, that time both carbon taken 1. Then 1 used up in making the bond, single bond. And now both carbon have, still both carbon has 1 electron. 1 electron. Then what will happen to this electron? Having 1 electron will be very, very reactive. Correct? Then that carbon which has 1 electron, what will happen? First to think, come this side, butadiene, that type there, that 3rd and 4th. Then these things, 4th carbon already, 4th carbon made bond with the styrene. Then 1 electron was there. Then now carbon in butadiene, carbon 1 and 2 double bond was there. That bond will also break. Correct? That bond will also break. Then both carbon will have single electron. Single electron. Then now second carbon electron and 3rd carbon electron which you got first time, both will make a double bond, because now 2nd and 3rd carbon they have 1 electron. Then they will become double bond. Correct? Then means their single bond was there it will become double bond. And first carbon will have 1 electron, means open valency. It will be opened. It can join with others. Then first carbon and last, in the last, after making the joining, last carbon, that will also will be opened. Correct? And all thing will be as it is. 6,5 H5 is already no different, no you can say different disturbance in C6H5. Just it will be there only. Correct? Either upside or down you can write. Then this repeat, this more long molecules now what you formed, both you have taken n molecules, n molecules, n molecules. It means n time it will form. It will be repetition. N times it will repeat. Hence finally you will write that in bracket monomer you will write, means what you got now that you have to write in bracket n times. This is actually polymerization. But both end will be opened. Both end will be opened. In the middle you can write that what you got polymer long means CH2 CH and CH double bond, again single bond CH2. Nothing happened, just you have joined. You remember, nothing you have done anything. Same things are you are writing. It is a big molecule. Then whole you have to write N, and out of bracket open you can say valence you have to write. C6H5 is already joined with the can say last carbon. Okay, this is called actually butadiene styrene copolymer. Here actually S means styrene, also S. Okay, I will tell you where S means sulfur, that also I will tell later on. Now here styrene is there. Okay, then butadiene styrene copolymer we can tell. This is called Buna S. Buna est S. Now second that is a co-condensation polymerization. Here you understand condensation polymers. What is the condensation polymers? Process is called condensation polymerization. Then here what I have discussed you, nylon 6,6, same reaction. Here H2O will go outside. It will be eliminated. Elimination reaction will take place. Correct? And why name has given condensation? Because now H2O went outside. It condensed. It became little small. Correct? That's why its name has been given condensation. Because now it is becoming little small. Simple meaning of condensation, condensed. Correct? In that sense. The condensation polymers are formed by repeated condensation reaction between two different bifunctional or trifunctional monomeric units. Bifunctional, like here you have said nylon 6,6, that is the, you have seen that here you have hexamethylene diamine, then two amino group was there, and in adipic acid two carboxylic acids are there, that is the bifunctional. Sometimes it may be trifunctional also, bi or trifunctional monomeric units. In this means both will join, different molecules, monomers will join here. Example, I told you nylon 6,6, reaction is same. Correct? The condensation polymers are formed by repeated condensation reaction between two different bifunctional or trifunctional monomeric units. In this polymerization reaction, the elimination of some molecules such as water, alcohol, hydrogen chloride, etc. takes place. It will go out. Generally water molecules, sometimes alcohol also, sometimes hydrogen halide means hydrogen chloride also. Okay. The examples of pterilene. Have you heard the name of pterilene? Might have heard. Terylene cloth, also called dacron. Another example is nylon 6,6, and third example is nylon 6 only. Okay, then nylon 6,6 reaction already I have told you. Nylon 6,6 is formed by the condensation of hexamethylene diamine with adipic acid. Okay, already I have told how both are joining. From the NH2, H bond will break, H will go as a H plus, N will become negative, and from the COOH, adipic acid side molecule, OH will go as OH minus, and carbon will become positive. Then positive carbon, negative nitrogen, both will join. Correct? And here H plus, OH minus, it will go as H2O. Then here NH2O will get water, and nylon 6 whole N you will get. Then this I have told you about the classification based on mode of polymerization. Correct? Means addition and condensation polymerization. Okay. Now I am going to tell classification based on molecular forces. Classification based on molecular forces. A large number of polymers applications in different fields depends on their unique mechanical properties. Then what are the unique mechanical properties? Like tensile strength, elasticity, toughness, etc. According to these properties, polymers are applied in different fields. These mechanical properties, remember what are the mechanical properties here? Tensile strength, elasticity, toughness, means hardness you can tell, how much it is strong, that is the tensile strength. Elasticity, how much it become long. Correct? Again it will come back. These are called mechanical properties. These mechanical properties are governed by intermolecular forces. What are the example of intermolecular forces? Then first example is van der Waals forces. Second example is hydrogen bonds. Correct? Then these van der Waals forces and hydrogen bonds will be present in the polymer. These forces also bind the polymer chains. Due to this force, they will bind the polymer chains. Under these categories, the polymers are classified into the four subgroups on the basis of magnitude of intermolecular forces present in them. Then first is elastomers. Okay, elastomers. Second is fibers. Third is thermoplastic, and fourth is thermosetting polymers. You remember that I told you there are four. First is elastomers. Second is fibers. Third is thermoplastic polymers, and fourth is thermosetting polymers. Details I will discuss in the next class. Okay, now I am stopping only here. Thank you.